So my name is Victor. We'll be talking about spatial data visualization for ecological hypothesis generation in rural Africa. So spatial data exploration and visualization has become a method that is fast gaining in many research disciplines. So visualization allows scientists and local communities to work together in building ideas of how local ecological systems work. So I'm going to present long-term data that has been collected in this ecosystem for over 40 years now. So we will be looking at the spatial and temporal trends of wildlife and livestock numbers, analysis of human attitudes towards wildlife, and possible dynamics of human-wildlife interactions. So this is our study area. It is almost 8,500 kilometers squared. What we're seeing here is the red line just shows the migratory area at the moment, but the animals used to migrate to the north and to south and utilize the entire ecosystem. We can also see the rainfall patterns of the ecosystem and the 5 by 5 kilometer grids that are used to collect the aerial data. So looking at the species population trends over time, we are seeing an increase in zebra population up to around 1990, and then changes, continuous decline there, and similar to wildebeest, and then a continuous decline there. Sheep and goats, this is abbreviated as SHORTS, on the continuous increase. And then you can actually see what is happening, the temporal dynamics of the different species that are happening, and you can begin to ask yourself why we have such certain changes at this particular time. So looking at the spatial utilization, we can be able to visualize different species and how they use the space. Species like zebra utilize different larger areas. I think it's because of they're used to coastal diet. Selective animals like wildebeest, they are more refined in terms of the areas they use. Giraffes also using the bush country a lot of the times, north of the Amboseli National Park. And then elephant and buffalo utilizing the park more. Elephants are bulk feeders and they tend to stay in the park because of high biomass concentration inside the park. So visualization of such information can give us a rough idea of how the different species utilize the area there. So talking about time series, spatial presentation of the changes in the early 1970s, wildlife and livestock used to utilize the area as shown here. We're seeing wildlife used to utilize quite a bigger area here in the early 70s, but currently there's a bit of displacement here. Livestock has kind of displaced wildlife to this central ecosystem, which we define as the minimum viable area. So possible causes of such displacement, as we are seeing here, evolution of settlement numbers, human settlement numbers over time in the 70s. We had just a few settlements scattered across the ecosystem. But if you look at the 2000, it's like the northern and the southern part have completely threatened to exclude the Amboseli National Park, and we're only remaining with the migratory area. So this is one of the possible causes of wildlife decline. So we did also wildlife species richness graphics to just show how it relates to human settlement densities. And we can be able to see that as the human settlement densities increases, the wildlife species declines here. This is at the 5 by 5 kilometers level. So a point pattern analysis also identified the 3 clusters of human settlements in the north, south, and apart from and sections of the east here, west of the park. Yeah, and the pastoralist communities are now becoming sedentary. So we were interested in just seeing the trends in wildlife, livestock settlements, and rainfall of the entire study period. We're seeing again wildlife being displaced from the north, livestock increasing, settlement numbers increasing, and rainfall hasn't changed much. So To just demonstrate how the species, one of the species utilize the areas, we deployed collars on wildebeest in the last, between 2010 and 2013. And we are seeing they utilize the areas outside the park, which are community owned. And then during the dry season, they concentrate inside the Amboseli National Park. This is the transition period, but now, as you're seeing live on your screen, is that they utilize the areas that are inside the protected national park. But as the seasons progress to the wet period, they begin to go out into the community areas, again, emphasizing the need of community conservation. So we did try a bit of a modeling here to just show how the settlement numbers and productivity per unit of rainfall. So we are actually seeing that the higher the settlement numbers, the lower the productivity. And we were also interested in getting to know the grazing pressure. This is from the vegetation. This is kind of pressure gauge to show early warning. So the good years are in the green, like in 1998, but the bad years, we have been able to see that as the seasons progress, especially in 2009, we saw a build-up from 2006 that led to one of the worst droughts in the ecosystem. People's attitudes towards wildlife vary as whether they are pastoralists or crop farmers. Pastoralists have problems with hyenas because they take down their livestock. Crop farmers have problems with elephants. So some of this will be used in agent-based modeling and Bayesian formulation in the modeling framework. So in terms of extent of fear, most community members fear also elephants, interestingly, as much as they also appreciate in terms of tourism. Lions also, people fear lions. They have a problem with hyenas, but they do not fear them. So to just summarize this work that we have done over the many years, working with local communities, we have formulated the hypothesis looking at the impact of human settlements on hydro productivity in relation to rainfall. So the model results suggest that both settlement spread and the numbers affect hydro productivity per unit of rainfall. We have done this exercise not only involving the community in data collection, but now we are taking them into the level of hypothesis formulation and modeling. The spatial co-occurrence also shows the strong interlinked movement and resources utilization of wildlife and pastoral ecosystems. So this is a basis for studying the interactions between livestock and wildlife and people also. So the next step that will be quite participatory is to come up with a land cover mapping of the ecosystem based on species habitat preferences, occurrence, feeding habits, and human attitudes. So we intend to use all these parameters to have a participatory map, again, working with community stakeholders and other related groups to have a map that shows where and when to do certain activities on this landscape. So it is quite a participatory exercise. So I would like to bring that to a close, and I'm happy to take a few questions.